Hello and good day, pre-algebra. We are going over our last objective of the unit, the last one we have yet to cover. CO44, which is the probability of mutually exclusive and overlapping events. Okay. So far we've talked about the probability of a single event. We've talked about compound probability, theoretical probability, experimental probability. We talked about odds. One more situation involves the phrases mutually exclusive or overlapping. Anyone have an idea? Have you worked with this before? Last year, maybe? 6th grade? Okay. So mutually exclusive events are events that cannot happen at the same time. Okay. Mutually exclusive events are events that cannot happen at the same time. Events that cannot happen at the same time. For example, okay, really every probability that you've come across so far has been mutually exclusive. You know, there are 3 red, 5 blue, 8 yellow marbles in a bag. What is the probability of choosing a yellow or a red marble? If you reach into the bag, can you choose a yellow and a red marble at the same time? No, if you only pick one marble, right, you can't pick more than one color. You know, none of these things, they can't happen at the same time. You will pick a red, a blue, or a yellow. Okay, boys? Whatever game you're playing together, let's focus up here. Okay? Whereas overlapping events are events that can happen at the same time. Okay? Events that can happen at the same time. So the difference between these two definitions, the words can and cannot. An example of overlapping events. An integer is randomly selected from the numbers 1 through 20. What's an integer again? This is on your general math quiz you took on Wednesday, kind of an integer-based question. What is an integer, Camille?
Isn't like any whole number?
It's not a decimal, not a fraction, right? So an integer selected from the numbers 1 through 20, you've got 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. No fractions, no decimals. What is the probability that it will be either odd or a prime number? Okay, so let's just write out all the possibilities here. You've got the numbers 1 through 20. You could pick a 1, 2, 3, 4, 5, 6, 7, 8. Oh, I better tighten up my spaces here if I want this to fit. 15, 16, 17. Okay, 20. It's good.
Hey,
You think after 15 years of teaching I would learn the spaces better, but no. Okay. So we've got our successful outcomes are either odd or a prime number. So let's underline the odd numbers in red. Okay. What would be considered successful outcomes for choosing an odd? We got a 1, a 3, a 5, a 7, a 9, 11, 13, 15, 17, and 19. And I needed to take a juice break. Where did I put it?
Behind you.
Oh, thank you. Okay.
same here.
Yeah. Another successful excuse me. Another successful outcome is a prime number. So we'll underline the prime numbers in blue. Okay. 2 is a prime. The only even prime. Fun fact there. What are some other primes? Between 1 and 20. What other numbers are prime? Raise your hand and tell me a prime number between 1 and 20. Abby. 4 is not prime. The definition of a prime is its only factors are itself and 1. Okay, 2 is prime because only factors are 2 and 1, whereas 4 has 1 and 4 and 2 and 2, so it would not be prime. Dave.
17.
17 is a prime number. Okay. Haley. 5 is a prime number. Okay. 19 is a prime number. Camille. 11 is a prime number. Griffin. 7 is a prime number. Jeffrey.
1.
1 is not a prime number, actually. Yeah, I know, it seems weird. So the definition of a prime, like I said, its only factors are 1 and itself. I didn't use a pretty important word. It's the technical definition is 2 distinct factors. Okay? Hold on. 2 distinct factors. And since 1 and itself is the same factor, it doesn't have 2 distinct factors. So 1 is actually not prime. But go ahead.
13.
13 is a prime number. Is that all of them?
Yeah.
There's one more. Shay?
15.
15 is not prime. It's also got 5 times 3. Colin? 3 is a prime number. Okay. 9's not. It's got 3 times 3. 15's not. It's got 5 times 3. But there we have it. Okay. Now, the mistake that folks make here when solving probability with overlapping events is they'll say, okay, I'm looking for an odd number or a prime. So let me count up the odds. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 odd numbers. Okay, 10 odds. And then let me count up the primes, because I also am looking for a prime number. I've got 1, 2, 3, 4, 5, 6, 7, 8 primes. Right? And so then what folks will do is they'll say 10 odd, 8 primes is a total of 18 out of 20. I have an 18 out of 20 chance of picking an odd or a prime number. Why is that incorrect? Why is that incorrect? Why?
Because you're reusing the odds.
Because you're reusing every number that we have underlined twice. You are counting 3 as both an odd and a prime. That's an event that can happen at the same time. 3 satisfies both successful outcomes here. They overlap. Right? That's where the phrase overlapping outcomes comes from. You don't want to count each one twice. Okay? And so instead, rather than doing this, right, we want to count up each successful outcome. 1 is successful because it's odd. 2 is successful because it's prime. 3 is successful because it's odd and prime, but we only want to count it once. Not as both an odd and a prime, right? 5 is counted once. 7, 9, 11, 13, 15, 17, and 19. So instead of having 18 successful outcomes here, how many do I actually have? Haley. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So the probability, I should give myself some more space. The probability of choosing an odd or a prime is 11 out of 20, not 18 out of 20. You see the difference there? 55%. Okay? 55%. Very, very good. You don't want to count those overlapping events twice. You only want to count them once. Questions? This is the first time that you've seen it, so if it's not quite, you don't get it, it's okay, but questions? I highly recommend you take the time to write out your outcomes when it's feasible. Writing out 20 numbers and doing it's not that bad, especially when you kind of start to work with this for the first time. Writing these things out really helps visualize how many successful outcomes you actually have. Okay? Let's look at another example. It says, write whether the event is mutually exclusive or overlapping, then find the probability in fraction form. Okay? So we have to first identify and then find it. It says you have 26 cards, each labeled with a different letter of the alphabet. What is the probability of you choosing a letter in the words SVDP or Royals? First of all, is this overlapping or is it mutually exclusive? Do you have any outcomes that would occur more than once or satisfy more than one successful outcome? Sophie?
Yes.
The S, right? Since the S shows up in both of them, you wouldn't want to count it twice. You would not want to, so this is the mistake, you would not want to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters out of 26. My probability is 10 out of 26. Right? Because what did you do? You counted the S twice. Okay? Instead, we don't want to count that first S or the second S. Doesn't really make a difference, I suppose. But we're going to eliminate that one and only take the VDP, ROYAL, and then the other S. So you actually only have 9 successful outcomes here out of 26. You don't want to count that S twice.
How many hearts are in a deck and a red?
Huh?
How many red and a heart?
Well, let's get there a little bit. Okay. So what do we decide? Is this mutually exclusive or is it overlapping? Overlapping, right? Because you have that S that showed up in more than one place. From the numbers 1 through 50, what is the probability of choosing a factor of 48? Now, we're not going to write out all the numbers 1 through 50, okay? But we are going to write out our successful outcomes here. What are the factors of 48? Factors of 48. Tony?
2, 4, 6.
2, 4, 6, those are all factors. 8's a factor. Kate? 12's a factor. 3 is a factor. Okay? 7 is not a factor. 7 goes into 49. 16's a factor. We're missing three more. 18 is not. 20 is not. 24 is.
22.
22 is not. Carter?
28.
28 is not. What? Someone said it. 1. And one other one. 48 is a factor of itself. Okay? Anything that appears more than once? Any overlapping outcomes? No. Right? 2, 4, 6, 8, 12, 3, 16, 24, 1, 48. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 successful outcomes, 10 factors out of a possible 50. Because we're using the numbers 1 through 50, there's no repeats, no overlapping. It is 20%, and it is a mutually exclusive event. Mutually exclusive. Nothing repeats, nothing overlaps. Okay? How are we doing? Good? All right. From a standard 52 card deck, what is the probability of choosing a red card or a heart? Now, for those of you that are familiar with decks of cards, what color are the hearts? Red. So if we're looking for a red card or a heart, are we going to have some overlap?
Yeah.
Yes. Okay? Because every single heart is also red. Right? So let's just kind of break this down here. In a 52 card deck, how many red cards are there? Haley. Half of them, right? 26. How many hearts are there? How many hearts are there?
This is a guess. 12.
Close.
13.
13. Okay. So we have 26 successful outcomes from the red cards, 13 successful outcomes from the hearts, but Jack,
We can't even count the hearts because all of the hearts are red cards. So
because hearts are red, every single one of these 13 hearts is already included in the 26. So all of these are not counted, which means it's overlapping because we have some repeats.
Oh my God.
And the probability is 26 out of 52. Are you writing the word hockey? Okay. Questions on that? Why it's overlapping, how we got 26? Yes.
How am I supposed to figure out how many vowels there are in the last?
You love to just kind of zippity-doo-dah day ahead. Okay? We will get to that one. We'll get to that. And if we don't, then you can ask me. Question on this one. All right. Let's see what we got coming up here. I'm going to let you, we have 2 left. Do the last 2 on your own. Rolling a 12-sided die, what is the probability of rolling an even number or a multiple of 3? For this one, I want you to write out, like we did with the 20, write out all the possible outcomes. You only have to go to 12. Okay? Write out all the possible outcomes. Underline all of your even numbers. And then underline all of your multiples of 3 so you can easily see if there are any overlapping results. Okay? So write them all out. Underline your successful outcomes, your even numbers, and your multiples of 3 to look for those overlapping results. What's that? 1 is not an even number. And lastly, in your class, what is the probability you choose a student with a last name that begins with a vowel? Blake, you can look around the room and you can go through everyone's last name, figure out how many begin with a vowel, and you can
Begin or end?
begin with a vowel, and you can figure it out that way. It's called research. Research. Okay.
Research sounds
Research.
very
Shay.
boring.
Okay.
Oh, wait. What's multiple?
A multiple would be what a number can go into. For example, the multiples of 5. 5, 10, 15, 20, 25, 30, and so on and so
It's
forth.
like 3, 6, none of your business. We're doing the first one. Oh,
Yep, and we'll go over these together. So I'm going to pause the video so you have a chance to work on them, and we will come back in a little bit.
Why do you need to know my last name?
Yeah. All right, and we're back. The probability of rolling an even number or a multiple of 3. Let's underline the even numbers in red. We have 2, we have 4, 6, 8, 10, and 12. And we'll underline the multiples of 3 in blue. Multiples of 3 would be any number that 3 can go into or that 3 can make. So 3, 6, 9, 12. Right? Is this mutually exclusive or overlapping, Carter?
That's not
Dayton?
Oh. M-E.
M-E.
Yep.
No. Evan?
I know. What? Oh, yeah.
You phone a friend. Liam.
Overlapping.
Overlapping. Okay. We have 2 outcomes here. I'm in black. We have 2 outcomes here that satisfy both being an even number and a multiple of 3. So the important thing is you don't want to count them twice. Okay. 2 is successful. 3 is successful. 4 is successful. 6 is successful. We're only count it once. 8, 9, 10, and 12 is successful, but only counting it once. So the probability is 8 out of 12. And it is an overlapping event. If you put 10 out of 12, your mistake was counting 6 and 12 twice, which you don't want to do that. Okay, there's only 1 6, only 1 12. In your class, what's the probability you choose a student with a last name that begins with a vowel? How many students are in the class, Haley? 28?
No, 29. 28.
1, 2, 3,
We
4,
have 28
5, 6,
today,
7, 8, 9, 10, 12. 28 present, although with 1 student gone, I would accept 29 also. Either one is fine. How many students have last names that begin with a vowel, Annie?
3.
3.
Jeez.
So 3 out of 28 or 3 out of 29. Either answer is fine. 4.
1, 2, 3, and then
4.
Where's your 4?
Island.
Already counted them.
We have an A, we have an E, we have a U.
Who do we say before?
I think that's it, right?
Dang, you said your last name begins with an A. Howard.
Howard.
I think it's only 3. Yep. 3 out of 28 or 3 out of 29. Folks, is this mutually exclusive or overlapping?
Not overlapping.
It's not overlapping. It is mutually exclusive. Okay. There aren't any results that repeat. Okay. That brings us to the end of the unit. Compound probability, we already talked about that. Here's your homework for the weekend. I want you to start, hold on. I want you to start making your help sheet. And what I want you to do is I want you to go through the unit and I want you to write down, this starts back all the way at CO39, I believe. Okay. I want you to write down all these key points. How to make a probability tree, how to do the counting principle, the definition of probability and the formula, what is theoretical probability, what is experimental probability, the law of large numbers. Just go through and write down all those definitions, all those key points in preparation for making that help sheet.
There's like an example.
The key is just the All right, folks, that's it, man. Have a nice day.